Okay. So this is the second class of the new topic that we started in the last class, which was the connected particle. And this thing is covering every other small topic that we have done before: the forces, resolution of forces into components, and resultant force F is equals to ma, the friction and tension, everything all together. This is all of this thing situation. The kinematics also can be involved over everything together. So this is a very important topic. If you can get the questions from this chapter done, this means that your the other topics are also good for you people. So this is a very good question from here I've taken out, and this is the one of the unique questions. One of the masses is hanging freely, and the other masses is standing, is on a inclined plane. So they have given us that there are two blocks P and Q of mass m and 5. So P is of mass m kg and this is of mass 5 kg. Q is of mass 5 kg. Are attached to the ends of a light inextensible string. Okay. Smooth pulley. Okay, rough plane. Rough plane means that there is friction over here. Okay. Inclined at 35 degrees. This is one of the very good questions, one of the difficult ones. Okay, so I think I brought out this question in the last class, but we did not attempt this. We did the easier ones. Now this is what have they given us. The block P is at rest. P is at rest right now, and Q hangs freely. The coefficient of friction between P and plane is zero point 0.2. So this is zero point 0.2 over here. Find the set of values of m for which the two blocks remain at rest. So we want the block to remain at rest. So this means that it can be on the limiting equilibrium. The situation, the right now the objects, the system should be at limiting equilibrium so that it remains at rest. Okay. Now for limiting equilibrium, there can be two situations. Either Q goes down, and the other one is either the Q goes up. So according to the motion of the Q, if Q is going up, this means that P is going down. And if P is going down, this means the force of friction acting on P would be to the left side. F max over here. Find the set of values of for which the two blocks remain at rest. Yes. So this is one of the case that Q is going up, P is going down, and the coefficient of friction, sorry, the friction would be acting on above, this parallel to the plane upwards. And the other case is when your Q is going down, so P would be going up, and in that case, the friction applying on P would be downwards. So we have to work with both of these situations. So this would be, if we write out the forces, this would be mg 5 times g, and upwards would be tension. And over here, case 1, let's do case 1. When your P is going downhill, P is going downhill. This means that the motion is downward. This is about to go down. So friction, force of friction would be above this, parallel upwards to the plane. And the weight component of this this P would be always down the plane, which would be mg sine 35. We learned that the weight component is always mg sine theta. And the what do we say? The normal component of the weight to the surface, this would be mg cos 35. F max, we know it would be equal to mu r, and the only force which would be opposing this weight component perpendicular to the plane would be the normal contact force. So these two are equal to each other. So the normal contact force is equals to the r is equals to this mg cos 35. So F max would be equal to 0.2 mg cos 35. Okay. Okay. Yes. So this means right now for this situation, if I this P is going down, so Q will be going up because your P is going down. So if I make up the equation for these things, for Q, the equation would become Q is going up, so tension minus weight is equals to 0. Or yeah, something like this. This would be tension, force of tension. And for P, it would be, um, yes, mg sine 35, which is the downward force, minus F max minus tension. This would be equal to 0. Okay. This is it. Set of values of m for which the two blocks remain at rest. Okay. So m, this F max can now be replaced with zero point 0.2 and mg cos 35 minus tension is equals to 0 and mg sine 35. So if this tension comes out to be 5g, so you can replace the tension with 5g. So 5g, you can take mass the common, so g sine 35 minus zero point 0.2 g cos 35 minus 5g is equals to 0. So mass comes out as, you can take the 5g on the other side, 5g upon g can be taken common out, sine 35 minus zero point 0.2 cos 35. G and G cancel out. 5 upon sine 35 minus zero point 0.2 cos 35. So 12.202 kg. This is the case when this is in the, what do we say, verge of moving down. This is the maximum or the minimum mass. Let's see. And the other case is when it is just on the verge of moving up. P is going upwards. So in that case, you would form the equation for Q, which would be the same, tension minus 5g is equals to 0. But for P, the equation would be something else. The P, for P, this would be the other way around. Now the motion is upwards for P. So F max would be acting downwards. So mg sine 35 plus F max and then minus tension. Mg sine 35 plus F max. Plus F max was 0.2 g 0.2 mg cos 35. And then minus tension is equals to 0. And tension was equals to 5g. Again, from here, tension comes out to be 5g. So mass taken common, g sine 35 plus 0.2 g cos 35 is equals to 5g. So g and g cancel out. I don't have space much over here. So mass comes out to be 5 divided by sine 35 plus zero point 0.2 cos 35. So mass comes out to be 6.78 kg. So this was the maximum value of mass for which it is in equilibrium. And this is the minimum value of mass for which it is in equilibrium. So, so if your mass is between this, then this is in, then this block will remain at rest. Okay.
Yes.
Let's do another one. Okay, this one. The particle P of mass 0.4 kg, Q of mass 0.5 kg, they have labeled it. At the end of okay, everything is the same. The system is released from rest. So initially velocity of both things are zero. With both particles at a height of 4.5, we can see that diagrams move vertically. Q does not rebound when it hits the ground. So they have told us that Q is going down. So P would go up. The acceleration of Q before it hits the ground. So for accelerations, we know we have to form the equations for both of them and then equate them, get the acceleration and the tension. So for the P equation would become, first we label them out. So this would be 0.4 g. This would be 0.5 g, the weights. This would be tension. This would be tension. And I told you, as long as the string is same, you would have the same tension for the complete thing. So uh, P is going up, so tension is greater for P. So tension minus 0.4 g is equals to 0.4 a. And for Q, if Q is going down, so weight component is bigger. So 0.5 g minus tension is equals to 0.5 a. So when you add them up, tension cancel out. 0.4 g minus 0.5 g. So 0.1 g is equals to 0.5 a. So a comes out to be 0.1 times 10 times, sorry, divided by 0.5. So this would be 1 divided 0.1 times 10 would be 1 divided by 0.5. So 2 meter per second square. This is the common velocity for both of them. Oh, sorry, acceleration. P would go up with this velocity and Q would go down with this velocity. Sorry, acceleration. P would go up with this acceleration, Q would go down with this acceleration too. So the acceleration of the Q before it hits the ground, it would be this thing. It would be 2. The time taken from the instant that Q hits the ground until P reaches its maximum height. This is the same question which I gave you in the first class. So P is going to reach down, which would be 4.5 meters. And then Q would be going up the same distance. As long as they were connected, they move the same displacement but in the opposite direction. But now Q would not rebound. They have told us that Q does not hit the ground and then does not rebound. But P, because of its final velocity over here, as it reaches this 4.5 displacement, it would have some final velocity which would take it a little bit more to the maximum position, maximum displacement. So that's what they have asked me. The time taken from the instant Q hits the ground. So first we have to start the time when Q is hitting the ground. This means when P is reaching over here. So here, this is the reference time. We have to find the time from here. Here till it reaches the maximum. The time taken from the instant Q hits the ground until P reaches its maximum velocity. Okay. I think Nadia is here. No, she's not here. Okay. So
Sir, I have a question. Sir, how is it 0.5 in 0.1 g equals to 0.5
sorry.
in
0.9. This would be 0.9. Good. Sorry. 0.4 a plus 0.5 a. 0.9 a. So this would be 0.9. So this would be 0.9. So 1.111 or 10 over 9 meter per second cube square. Good. Sorry. Okay, the rest of it, I think. So we have to find the final velocity over here. So v is equals to u plus at, or we can use 2as is equals to v square minus u square. So 2 acceleration is 10 over 9. Displacement, we know they are going to cover 4.5 meters. Final velocity we want to find. Initial velocity was 0. So v comes out to be 2 times 10 over 9 multiplied by 4.5 square root of 10. Square root of 10. V is square root of 10. And now they want, now after this situation, after this, now the particle P would be in free fall motion. After this, because the Q is now rested on the ground, so the string would become slack. And when the string is slack, now the particles will move independently. So P would be now experiencing this G, which would be downward of minus 10 meter per second square. 10 meter per second downwards. Okay, we have given the direction with the arrow downwards. So how much more time will it take? V is equals to U plus AT. Final velocity to reach the maximum displacement would be 0. Initial velocity is under root 10. Acceleration is negative 10 because this would be stopping the, because it would be downward, and time. So time comes out to be under root 10 divided by 10. Under root 10 divided by 10. 0.316 seconds. So this is the time. 0.316 seconds. That's it. Then the total distance traveled by P while Q remains at rest. So how much distance P, the total distance remain traveled by P while Q remains at rest. So P would reach this maximum height and then come down again. So along its this interval, Q would be at rest. So the total distance traveled by P while Q remains at rest on the ground. Okay, so this total. So first we find this total displacement, how much it has moved up. So you will multiply that by 2. So how much it has moved up is 2as is equals to v square minus u square. So 2, acceleration is minus 10. Displacement, we want to find it out. Final velocity is 0 at the maximum point. Initial velocity is under root 10 whole square. So s comes out to be negative 10 upon 2 times negative 10. So negative 10 cancel out, half meters. So it would move half meter up and then half meter down again. So the total displacement, total distance that P will travel is 1 meter more. ठीक है? Okay, let's do another question. This was it. This is a very good one. So this is from Edexcel, but this is very much relevant to us as well. So we should be able to do this one. So they have given us a particle A of mass 4 kg is held at rest on a rough horizontal table. So this is rough. Particle A is attached to one end of the the fix is okay. Mass of 3 kg, which is B, okay, hangs freely below P, okay. The part of the string from A to P is perpendicular to the edge of the table AB. Blah, blah, blah. Everything is that is drawn over there. They have explained it in this paragraph. The string is modeled as being light. Okay. Everything is. The system is released from rest with the string taut. Right now, the string is taut, and the string, the AP string is 2 meters. Okay, we'll consider that as well. Between the block A and the pulley, there is a distance of 2 meters, and B is 1.4 meters above the horizontal floor. After descending with constant acceleration 2 seconds, B hits the floor, does not rebound. Show that the acceleration is 0.7. So right now we don't even need the F is equals to ma part or doing the equations for A and B separately. They have given us that B is traveling 1.4 meters, and time is 2 seconds, and constant acceleration. They're asking for acceleration. So they're asking us to show the acceleration of B before it hits the floor. Okay. So what more do we have? 2 meters, 1.4 meters above. So 2 seconds, hits the floor, does not rebound. Show that the acceleration of acceleration of A before B hits the floor is 0.7. So V is equals to U plus AT, or Final speed, we don't know. We would have to form the equations. Here's the floor. Constant acceleration for 2 seconds. Initial velocity, we know it would be 0. Final velocity, we don't have it. S is equals to ut plus half at square. We can apply that. Ut plus half at. Yes, we can apply that. S is equals to ut plus half at squared. So S, we know it is 1.4. Initial velocity is 0 plus half a t is 2 seconds squared. So 4a upon 2, 1.4. So a comes out as 0.7 meter per second square. That's it. This is what that asked us. Look, so we did not need the equations right now. State which of the modeling assumptions you have used in order to answer your part A. With a modeling assumption, this is a particle, exact particle, point particle, और क्या to answer your part A. Acceleration is
We
constant.
haven't taken friction into consideration, right?
क्या
फ्रिक्शन का वो म्यू ने भी नहीं लिया ना इसमें.
अभी नहीं किया ना. अभी तो हमें सब कुछ बता दिया था कि B, how is B moving, with what speed, sorry, what time it took, and how much displacement is it covered. Initial velocity was 0.
तो मैं वही कह रहा हूँ, बी का आंसर ये नहीं हो सकता कि we took as a smooth surface.
No, we haven't considered. This is not a smooth surface. This is a rough surface. We're not assuming it right now. अभी तो हम forces को देख ही नहीं रहे ना. We're not considering the forces part for this part. They have given you that after this complete thing, this resultant, this is the result, that it is traveling 1.4 meters in 2 seconds, and initial velocity was 0. So we are just considering this information to form the equations for sum of forces equals to ma. Then we would consider this as well. The force of friction is there. Okay, this is the resultant thing after the friction is being applied. Modeling assumption is that I think the acceleration is constant. This is the assumption whenever you use this what do we say, this equation of motion. We know that these are only applicable when your acceleration is constant. We'll confirm this as well. This is June 2020. There can be many assumptions as well. Point particle, and it does not rebound. Okay, everything okay. Okay, let's move on forward. Find the magnitude of the resultant force exerted on the pulley by the string. Find the magnitude of the resultant force exerted on the pulley by the. This is a very good question. So we know that there is a force of tension upward, and definitely this would be pulling it to the right side. And I told you that it works on both ways. The force of friction, the direction works both ways. So for the point P, the pulley, this tension and this tension is pulling it like this, pushing it like this. And for the string, for the masses, it is pulling it like this. So we want the resultant force on this particle, on this P point, on the pulley, the resultant force because of these two tensions. So first of all, you would have to find the value of this tension. How much is this tension? And that would be how much. We know for this one, the weight is mg, right? So if I form the equation for this particle B, F is equals to ma. So sum of forces, we know it is going down, so weight is greater. So 3g minus tension is equals to 3a. Acceleration, we know now the acceleration with which this particle B is going down is 0.7. So 3 times 10 minus tension is equals to 3 times 0.7. So this becomes 30 minus 21. Oh no, 30 minus 2.1. 30 minus 2.1. 30 minus 2.1 is equals to tension. So tension comes out to be 27.9 Newton. Okay, All good till here? Weight is mg, 3g, and tension is equals to ma, 3 times acceleration, we know it is 0.7. Okay, and now on the pulley, if I take the part of the pulley only, let's suppose this is the p point pulley. There is a point which is pulling it like that. This is tension, which is 27.9, and this is the also the tension, 27.9. They are asking us to get the resultant force because of this, right? Find the magnitude of the resultant force. So the resultant force would be the sum of horizontal forces is negative 27.9 on the left side, and the sum of vertical forces is negative 27.5, 27.9. So the total resultant force would be the square root of the fh squared plus fv squared, which would be 27.9 squared plus 27.9 squared. This is 39.57 Newton. This is the resultant force that is acting. And the angle at which this would be acting would be 45 degrees, exactly like this. They're not asking you for the angle right now, but if you find the angle as well, this would be tan inverse of the vertical minus the horizontal, divided by the horizontal, right? Sorry, this is the resultant force, which is right now 39.57 Newton. Okay, do you get this?
Yes, sir.
Yes, sir.
Then the coefficient of friction between the A and the table is mu. Find the value of mu. So we'll have to form the equation for this thing. Now we know that B is going down. So A would be going like this. So if A is going like this, then the friction would be on the left side. So friction is towards the left. Weight of this would be mg, 4 times 10. So 40 Newton. So normal contact force would also be the same, 40 Newton, which would be opposing the weight. So if I form the equation for this particle A, the tension is greater. So tension minus F max, which would be mu times 40. Mu times for mu n, mu r is equals to ma, 4 times 0.7. I don't know why was it of 4 marks. Right, the mass of A is 4 kg and the acceleration is constant, the same between for both of these, because both of these were moving at the same, what do we say, common acceleration, they were connected together. So we just solve for this tension. We know now the tension is 27.9 minus 4 times 0.7 would equal to mu times 40. So mu comes out to be this thing, the left side divided by 40. So 27.9 minus 4 times 0.7 and this divided by 40. This is your mu, 0.6275. Okay, any questions? All good? Why was it of 6 marks? This was of 6 marks. This is looking very fishy right now. Have I done it right? Think about it. Find the value of mu, the coefficient of friction between F is equals to ma. Tension we know 27.9. Yes, I think I've done it right. Okay, determine by calculation whether or not A reaches the pulley. Okay, we know if this thing is going 1.4 meters down, this would be moving 1.4 meters to the left right side. And after this position, they would now be moving as independent objects. They would now, the string would now become slack because B is resting on the resting on the floor, so they would become slack. And after that, the acceleration of the particle A, we'll have to find it out. Friction would still be there, right? So there's only one force which would be stopping it from going to the right side, which is the friction. So F max would be the same, 40 times 0.6275 mu n, and this would be negative, is equals to ma, which is 4 times acceleration. So acceleration would come out to be, the tension is now finished, right? They are now moving independently. Tension is 0. So minus 40 times 0.6275, and this thing divided by 4. This is giving you negative 6.274. So how much more distance will it cover up until it reaches, up until it stops, the final velocity becomes 0? So 2as is equals to v square minus u square. So 2 acceleration minus 6.275 displacement we have to find out. If this displacement is more than 0.6 meters, then it would definitely touch the P. So velocity is, final velocity should be 0. Initial velocity we know. Now we'll have to find the initial velocity as well. How much would be the initial velocity when it would travel 1.4 meters? I think we found it before, or no, we haven't found it. So what would be the initial velocity over here? So v is equals to u plus at. No, we can, yes, we can use that. At final velocity is equals to initial plus acceleration was 0.7 and time was 2 seconds, right? The time it took to for B to go down will be the same time it took for A to go to reach that point. So velocity is 1.4 meter per second square. 0.7 and 1.4. Okay, so 1.4 initial velocity, and the displacement, let's see. I think it won't be negative 1.4 square divided by 2 times negative 6.275. So 0.1562 meters, which is less than the 0.6 meters. So this means it will not reach P, isn't it? It will stop after this, moving a few more 0.156 meters. Okay, do you get it?
Yes.
Nadia or Nuba, Murtaza?
Yes.
Let me confirm this. I don't know, this part D was of 6 marks, but we did it in 3 lines. MS. It was question number 7. Point 7. Tension is 39. Resultant was 39. Cos 45. 2t cos 45. What did we get? The resultant tension.
So you got the same.
29. 39.6. Why did we get 39.6? Tension, we found the tension wrong. Tension would be 39. I think their G is 9.81. They use the G as 9.8. I forgot about it. Look, 3 times 9.8 minus 3 times 0.7, 27.3. And then square root, this is square plus this is square. 38.6, huh? So the Edexcel one, they have the G as 9.8. Okay, so we've done the right thing. Mu is coming out as 0.625, very close to the, because of the difference of the G, we're getting the other, but it is very close. So I don't know this. This is really the same thing. Let's use the G value 9.81. So 27.3, right? We got the tension is 27.3. Let's see. So if we use a 27.3 over here, 27.3 minus 4 times 0.7, this thing divided by 40, 0.6125. Hmm. 27.3 minus 4 times 0.7 divided by 40. 40 G, sorry, 4 times G, 4 times 9.8, 0.625. So we've done the right thing, okay? Just the difference is that we have used the value of G as 10, okay? So this was it. This was of 6 marks. I don't know why. And then it is not reaching, does not reach the pulley. Okay, that's it. You've done it right. Okay, all good. Now I have some, what do we say, confidence. But still, they should not have made the 6 marks. Okay, copy this down, take a screenshot or anything. This was a very this was, I think, a reverse engineering question. We found the acceleration and first, and then we used that to find the tension. Then we use the tension to get the mu. Everything is reversed. Sometimes the question looks very difficult, but when you start doing it, it's not that. It's more easy if your basics are strong. So the diagram shows particle A, mass is given, particle B, mass is given, inclined at an angle 30, 60, everything that they've given us. In the diagram, it's written down. The plane is the plane smooth or okay. In the first part, they're telling us that both planes are smooth. Find the acceleration of A and the tension in the spring. So this is for this thing again, you'll have to break it down into components. So the weight component would be 0.8 G sine 60, and this would be 1.2 G sine, oh sorry, this is 30, this is 60. There is no force of friction, so there is no need to find the normal contact force. There would be tension over here and there would be a tension over here. What would you assume right now? Which one is going down, which is going up? We need a logical assumption. I told you whenever we start off with forming the equation. Which one do you think would be going down and which one do you think would be going up? Nova? Any idea?
Sir, B
No,
is like
1.2 go down.
B. Looks like B would go down to me as well. Because one thing that is supporting this claim is that it has a higher mass. And the other thing which is supporting the claim is the angle of inclination. When you have a higher, more inclined plane, then the weight component is bigger. Think about it. Cos sine 60 would be, sine 60 is root 3 over 2. And sine 30 is half. So root 3 over 2 is bigger than half. So whenever your inclined plane is steeper, your weight component is bigger than the normal component parallel to the perpendicular to the plane. Okay, so assumption right now is that B goes down. So following this assumption, we formed the equations for B and for A. So if B is going down, this means the weight component is bigger. So 1.2 G sine 60 minus tension is equals to 1.2 A. Then for A is going up, so tension would be bigger. 0.8 G sine 30 is equals to 0.8 A. So tension cancel out. 1.2 g sine 60 minus 0.8 g sine 30 would be equal to 2a. 1.2a plus a 0.8a will be 2a. So 1.2 times 10 times sine 60 minus 0.8 times 10 times sine 30. This thing divided by 2 is acceleration, which is 3.196 meter per second square. And you can see this is coming out as positive. This means that the assumption that we have taken is correct. B is actually moving down. And then they're asking you to find the tension as well. So tension would be equal to, we substitute the value of A for any one of them. So this is the answer. Multiply this thing with, I'm substituting it in the second equation over here. So 0.8 times this acceleration plus 0.8 g sine 30. So the tension is coming out to be 6.557 Newton. That's it. So easy 6 marks. Look, so the question was very much on the outside looking difficult, but it was the same thing. It is given instead that both planes are rough with the same coefficient friction mu for both particles. Find the value of mu for which the system is in limiting equilibrium. So both have same coefficient of friction. So assumption would also be the same, that B is still trying to go down. Okay, because B is higher mass, greater mass. So this means the friction would be lesser for B than for A. Sorry, B is trying to go down. So friction for B would be upwards. A is trying to go up. So the friction of A would be downward. Okay, downward. So this would be F max for A and for B. So now you would have to find the normal component as well. That would be the normal force. This would be the same as the weight component inside the plane, perpendicular to the plane, which would be 1.2 g cos 60. This is N for B. Okay. This is N A, and this will be the same as the normal component inside, perpendicularly inside the plane, which would be 0.8 g cos 30. So we can find the F max for A, F max for B. So the second equation for B, the equation become 1.2 g sine 60 minus tension minus force of friction, which would be mu times N. N is 1.2 g cos 60 is equals to 0. And for A, tension minus 0.8 g sine 30 minus mu tension, yes, tension is upwards, so minus mu 0.8 g cos 30. So your mu should come out to be positive. If your mu comes out positive, then that's a good sign. So this tension, when you would add up these equations, tension and tension would cancel out. So 1.2 g sine 60 minus 0.8 g sine 30. Is equals to, if I take both of the mu's on the right side and take mu common as well, they would both add up 1.2 g cos 60 plus 0.8 g cos 30. So yes, look, the mu would come out to be positive, I think. 1.2g. Let's form a single fraction. 1.2 times 10 times sine 60 minus 0.8 times 10 times sine 30 divided by 1.2 times 10 times cos 60 plus 0.8 times 10 times cos 30. So your mu is coming out to be 0.494. This is the final answer. That's it. Okay. 6 marks. Easy 6 marks. 3 lines and 6 marks. Look how am I showing this one complete working. I don't change my every term in decimal. I keep them exact. And then I use the calculator to the maximum capacity, everything that I can use. And I use it properly, then put the values properly. And I get the one answer for all everything. It's instead of inputting everything separately, converting them to decimal and then solving it and then inputting again and again and again. Make a one complete proper equation, put in the entire thing properly in the calculator, you'll get the final answer.